And because we looked up OBS Studio, I might start to use that next time, so we can do a live stream to YouTube. So there's nothing to upload after that.
Yeah.
We just looked up. Open broadcast streaming, and YouTube. Can hook onto OBS or Open Broadcast Studio. That's it. Okay.
Yeah.
And so I might be able to stream directly to YouTube instead of having to save it to a file and then upload it later. Which is
would be
cool.
great if for those of us who are occasionally run late or can't get here, we can get on from home or on the go.
Yes, but that will be. I think that might encourage in the end more people to be just sitting at home and just watch the stream. All right. So today's topic. Okay, let me turn on the mic here. Make sure that it's not too loud. Okay, so because somebody asked about how to use a camera and take pictures and process the images and stuff like that, that's what we'll talk about today. Yeah. Okay, so it's actually not very easy. I would consider this one more difficult than using SQLite or sockets. Because those two, for the most part, you're just making some static calls and nothing really happens unless you do something. This one is a little bit more difficult. Okay, so we'll go ahead and there's already a sample program there's a sample program already done. So you just go to the shared drive. Okay, let me go to the shared drive. It's called Camera 1. So you go to the 363 shared drive. I'm going to download it so I can actually run it here too. You take a look at, did I put it to the wrong place?
You added in an Camera 1 IANS thing.
Yeah, but where did I put it?
If you click on it, it should show where it is, or at least let you download.
Okay, I uploaded it to the wrong place. Okay, it shows the content. Okay, so where is it? Okay, there we go.
It just wasn't showing for a minute.
Huh, that is weird.
I just downloaded it so it was there.
Yeah, okay, that is weird. Okay, so if you want to follow along, you can just download this particular program. It's done in the sense that I can get a preview out of the camera. It is not done in the sense that it doesn't really do whatever is expected when you switch applications or when the activity is gone. So it's kind of done and kind of not done, but I think it has got most of the most important stuff done. Okay, so that's the most important part. So let me go ahead and unzip Camera 1 and start up Android Studio. Android Studio did not get any updates since last Wednesday, which is strange in a way. Alright, so we'll go ahead and import from Camera 1, build.gradle. And also, I wrote some notes too, because this one does require a little bit of explanation. So I included some notes on my website, so you can read the notes and also refer to the sample code at the same time. Right. So the notes is module 0272, and it talks about how to use a camera in Android. And I basically try to cover topics that are not covered in the Android developer pages, because otherwise you can just go over there and figure out how to do stuff, right? Okay, so the main concept about the camera is it is considered a source, and in many ways this is actually a little bit different from a socket or from SQLite or from any other resources that we have talked about so far, because this particular source is always spewing out stuff. Okay, so all the video data or the image data is always being spewed out. So the question is, how do you hook up to this stream, tap into it, and then only say, okay, I want a picture right now. Okay, so as it turns out, there are many steps involved and many concepts involved too. So we have the concept of a source. A source is basically the camera itself. So in order to make use of that source, you have to understand what is a sync mechanism. A sync mechanism is basically something that listens to a source, but a sync itself does not automatically always capture something. It is just connected to a source. It doesn't actually do any capturing until you say, okay, I want to capture now. Okay? So these are the main concepts. Before you actually make the camera code work, so one thing you have to remember is to make sure that you request the camera permission. Now this is easy to do because you just have to add that one line in Android manifest.xml, which is pretty easy to do, but it doesn't do the entire trick. Okay, because in later versions of Android, even if you have this line and the application installs, it still doesn't give your application permission to use the camera at runtime. So you will still have to ask for camera permission at runtime, and the end user has a chance to deny that at runtime too. So you have to kind of be able to handle what happens if the end user decides, okay, I don't want to give you access to the camera. Then you have to make your program not crash and just okay, without the camera, you lose some functionality. Is that okay? All right, so this is a link to the Android document that explains how runtime permission requests work. Okay, and it's not easy because just like anything else in an user interactive application, when you request a permission, the request call returns right away. Doesn't take much time, and then it pops up a dialog box on screen. And then when the user enters, yes, I want to allow permission, or no, I do not want to allow permission, it generates an event, and then the callback is going to be called so that you can actually handle the case. Okay, the end user denied the request, or the end user grants permission to the camera. So you have to handle that code in a kind of disjoint fashion, and you will find that in order to work with a camera, there are a lot of code like that. Okay, you make a request, the request comes back right away, doesn't tell you whether it was successful or not. But then you have to specify a callback. Okay, and then the callback will eventually be called, indicating whether whatever you requested earlier was granted or successful or not. Okay, so we'll see a lot of stuff like that today, more so than when we talked about sockets. Okay, so 3.2 is really the main section of this notes here. It's basically just an outline of all the quote-unquote necessary objects in order to make use of a camera. The program itself has all of this code already, okay? And obviously, if you go to the Android website, we go to the developer pages of the Android website, it has individual pages for each class or each interface that we'll be talking about. But what Android does not have, the developer site, is something that kind of put everything together. It has a lot of tiny little pieces, but not enough glue to kind of put all the pieces together. Okay, so, but that's okay because they target people who have been writing programs for 10, 20 years, so they may not need all the glue. They can just kind of figure out things on their own. I needed almost an entire weekend to figure this out.
Thanks.
Sure. I mean, it was fun for me. I mean, this is the kind of stuff that I like to do. My wife was out in the yard, and I was doing all the coding in the house. We both got to do what we like to do. Okay, so the first thing you might want to know is what is a camera manager object. Camera manager object represents an interface to the camera management of Android. It's because camera management is not something that is specific to your app. This is actually a system-wide resource. So you need to use a camera manager object in order to say, okay, tell me about all the available cameras. That's one thing it can do. It can return a list of IDs of every single camera that is accessible from your Android system. And then once you get a list of those IDs, you can query each one using the camera manager. You can use the ID to query, okay, tell me more about this camera. What can it do? What kind of resolution does it have? What kind of output does it have? And so on and so forth. So it does give you, a lot of useful information. So this is the second one. When you query and say, okay, tell me more about this particular camera, then the camera manager, using the method getCameraCharacteristics, is going to return an object of this particular class, camera characteristics. Okay, not very surprisingly. And that represents the characteristics of a specific camera, and all cameras are identified by the IDs returned by, I think it's called camera list or something like that, with the camera manager class. And this also uses a key value pair mechanism, so you can just say get, and then you specify what you're getting, and then it will return whatever you're getting. One of the objects that you can get is a stream configuration map. So this is the third level down. So a stream configuration map object is one of the many values of a camera characteristics, but this one requires the specific key of this one, which is a camera characteristics scalar stream configuration map. Whew, that's a lot of words. This one has one specific thing that we need. Okay, so I won't talk about anything that is kind of like peripheral, but we don't actually need it. This one we actually do. Because what you need to do in this one is to use get output formats, which is a method of a stream configuration map object, and it returns an array of size objects. In other words, you can use this particular object and say, okay, tell me, if I try to capture this stream, what are the sizes of images that I can capture? So depending on the camera, okay, some cameras do not have a lot of flexibilities, and it always wants to give you like full resolution pictures in JPEG, okay? But with some cameras, it can give you, scaling. You can basically look at a long list of supported screen resolutions and pick one that you think, okay, this is the one that I want to use. Is that okay so far? Making any sense? So it gives you an array of size objects. And the size object doesn't really do a whole lot. It gives you the width, gives you the height, and a few other things, but it's nothing really fancy, okay? But you will need this in order to set up the next few things. Are there any questions at this point? Yep.
Like phones have two cameras. Are you pre-selecting the camera that you need?
You will have to figure out which one is the front and which one is the back based on the characteristics. So there's one particular attribute that will tell you whether it is rear facing or forward facing.
And that's in characteristics?
I think it is in camera characteristics, not in stream configuration map. The stream configuration map is basically saying, okay, if I were to intercept this stream, what do I need to know about it? So it's not about the device, which way it's facing, it's about the stream itself.
Okay.
But camera characteristics has to do with the camera itself. Is it forward facing? Is it backward facing? Is it available? Can I use it now? That sort of thing. Okay. So the next one is the major one. A camera device object is representing a specific camera on the Android device. Now, you cannot just say new and create a camera device. This one is only returned a reference to an object of camera device class. It's only returned by a callback that is corresponding to a request to open the camera using the camera manager object. Okay? I know this is all, when I show you the code, it will be a lot more clear. Okay? But it's a very indirect process. So you use a camera manager object to say, I want to open this particular camera using the ID. But that call returns right away. But in the call, you will have to supply a callback object. Within the callback object, it will specify a on, connect, or camera connected, that sort of method. And then within that method, you'll be given the actual camera device reference to the object that is actually connected. Okay, I will show you the code. By the time we get to the code, it'll be a lot more clear. And the reason that we have this kind of setup is because it might take quite a bit of time for that call to finish. Because the call to request a connection is sent basically to the operating system. You're basically asking the operating system and say, can I use this particular device? And this is exclusive too. The camera device cannot be used by multiple applications at the same time. But it can be used by the same application in multiple ways at the same time. Yep.
The control is done by the OS?
Yes.
Okay.
So the control is done by the OS. The OS can basically say, whoop, you cannot use it.
Okay.
Yep. On the sync side, so this is all on the source side up to this point. On the sync side, which is basically something that is consuming the stream coming out of the camera, the starting point is going to be a surface view. A surface view is something that you can actually put into the layout. It is one of the elements that you can put into the layout. But as something that you put into the layout, it doesn't do a single thing. In fact, you don't even want to change its size, because the actual size of the surface view should depend on what resolutions are supported by the camera and which one you choose to use. So it doesn't make any sense to preset what you want to use on the screen, because it depends a lot on what your camera is actually supporting. Is that okay? Okay. And what makes a surface view different from all the other views is it contains a surface. Okay, a surface is a specific class. But a surface has you cannot access a surface directly, or you can, but a lot of management of a surface is not done by the surface itself, it's done by a surface holder object. A surface holder is basically an interface, but a surface holder object is always associated with a surface view in order to control the underlying surface object of a surface view element, UI, user interface element. Now there's a reason why we have a surface holder interface instead of putting all of those calls directly into surface view, because we don't want to overburden a surface view to include things that are very specific of handling a surface. So that's why a surface holder interface is created for that purpose. Okay. Whatever logic that needs access to a surface object should attach to the surface created method, because it is not always possible for a surface holder to return the surface itself. There may be sometimes when a surface holder does not actually have a surface connected to it. So if you do need a surface, which is what you need to capture the output stream of a camera, you have to attach that code to the surface created method of a surface holder.callback interface. So we'll see all this code, okay? Because the English description is actually more confusing than the actual code itself. But it is useful to understand all of these concepts outside of the context of the program. Once you have a surface created, its size should be configured using the set fixed size method of not the surface itself, but the surface holder object. And this size should be one of the sizes supported by a camera device that we talked about a little bit earlier, using the stream configuration, can't remember the name, stream configuration map, yep. Okay, so getting all the way down here, so we're almost there, okay? So once you have a surface, it is configured or it's sized correctly, then the last thing you need to do is to create or get a camera capture session. Now that is also a multiple step thing, okay? So the first thing you have to do is to get a camera request builder object. Then you configure the builder object itself by specifying, okay, who are going to be the consumer of this particular stream. Once you specify who the consumers are going to be, then you say build using the builder object itself, and then it will give you an actual request. It will become a camera request. And then what do you do with a camera request? is to use it to call you use it to you pass it to the method of set repeating request or something like that, and that one will eventually make the connection between a surface and the output stream of a camera, and then you can optionally specify what to do when a capture is done. Okay, so that's a general description. I didn't have time to draw a picture, so I can draw a picture on the whiteboard right now. Okay, so there are two sides. Okay, so there's the provider or the source, and there's the consumer, which is the sink side. Okay, so on the source side, which is the camera, so you have the camera hardware, which you cannot access directly. So this one, this is a specific camera. It is represented by a camera device object. Okay, but you cannot get to this one directly because you have to use a camera manager object in order to know what cameras are even available, and then the camera manager will eventually give you the camera device object. And then on the other side, you start off with a surface view, which has a surface holder object associated with it. And then the surface holder at some point will have an actual surface associated with it. You need to tie these two things together. And the thing to tie them together is a capture request. So you have a capture request to kind of tie these two together. So what is going to happen, if the capture session does go through and it does work, then what is happening is the operating system, not your own thread, the operating system is going to take the output stream of the camera device and put it into the surface that you want to fill up. When the surface, which is a frame buffer, is filled up, then you can potentially have a callback and say, okay, this is what I want to do when the capture is done. Or optionally, you can say nothing, such as in our sample program, because it's a repeating request. We just basically say, okay, just keep doing it. Okay, so it will basically refresh the buffer as much as possible, but we are not actually doing any other custom processing. Is that okay? All right. So maybe a quick view of the source code is good at this point, now that we have talked about most of the concepts. And this time we only have one single class. The manifest is over here, and I have one extra thing that is not actually needed, so you can take this out if you want to. But you do need to specify a camera permission. It has to do with which version of Android this app is going to be running on. If it's going to be running on an older version of Android, then this will pop up when you install the application, and only at that time somebody can either grant or deny access to the camera. If you install this app on a newer device, then the access to the camera or the permission should be asked during runtime. It's when you run the app that you ask the end user to grant you permission to use the camera, not when you install the app. Okay. So most of the code is inside main activity. Just one more thing in the resource. Okay, really easy. So in the resources, in the layout, this is the layout. Super duper easy. Because the only thing we're including here, okay, where's my zoom control? Change the layout a little bit. Infer constraints clear. Where's the zoom? Do you guys see the zoom anywhere here? Or am I just missing something entirely?
Yeah, try making, yeah, there you go. On mine it's in the top right corner.
Okay,
Yeah, it's like that.
hide that, there we
you
go. Okay, so I only have one single thing in this entire activity, which is a surface view. That's it. And the properties of the surface view is to make use of wrap content for both the height and also the width, and also give it a name, make sure it has a name so that we can refer to it, and that's it. This is everything that I need for this entire application. Okay, so most of the code or most of the things that we have to do is inside main activity itself, which is a pretty involved process compared to any one of the other sample programs that we have done so far. So what we'll do is we're going to start with on create, the usual thing, because this is one of the first entry points that we have access to. So it has all the usual stuff except for the last call, which is get camera configuration. Okay, so there we go. We have get camera configuration here, which is a private method. So I think it's Alt-Enter to get there, right?
It's command-click.
Command-click?
You don't have a command button. You have a. It's probably Control-click or something.
Control-click. Yep, Control-click does it. So this is get camera configuration. It doesn't actually do much. Okay, it doesn't do much for one particular reason. I don't know whether I have permission to access the camera at this point. So the very first thing it does is to check. Okay, well, I take it back. The very first thing it does is to remember a camera manager object, which is stored inside the object itself, inside the activity object itself. And this is done by calling get system service using the name system context.camera service as the key, and it will return an object in general. But since I know that object is going to be of the class camera manager, I cast it into a camera manager before I remember that object. Okay. This is going to be useful, in several subroutines, and that's why I have to keep it as a private member of this class. Okay. So the first thing I do is I make this call. I'm checking whether the permission of using the camera is already granted or not. Now, if it is not granted, which means the answer is not equal to permission granted, then the next thing I do is to request the permission to do it. So when you call this particular subroutine, which is a static method of activity compat, all it does is to show up a dialog on the screen and ask the end user, do you grant permission to use the camera? But since you don't want to block this process, you don't want to block this particular thread, you basically just this call returns right away. What about the answer? Did the end user type yes or no? Well, you won't get it from the call itself. Okay, and that's why we have to specify. No, in this case, it doesn't actually specify it because the object itself, this, is actually it's implemented the interface to deal with the result of a request to get permission. And that part is visible from the declaration all the way to the top here. Oh, never mind. It is actually provided. I just have to override it. You can see this override. The on request permission result is the handler of, okay, when the end user clicks yes or no, this is the callback to let the application itself know, okay, you asked whether we can have permission to do blah blah blah. This is the answer from the end user. Okay, and it gives you the option. Okay, let me scroll back to get camera configuration. The third parameter of request permission is an integer value of your own choice, of your own choosing. So this is the ID of what you're asking for. When you get it back from the on request permission result call, it is also going to be passed back, and that's why I'm only checking that one to see whether it is permission granted. And if it is granted, then I just say, okay, camera permission granted. Let's go ahead and do some more stuff. Is that okay?
Are you sure it's granted? Or is it in the list of permissions?
it is in the list of permissions, and the grant result is what is containing that.
Is request code something you declare, or is that one of the built-in?
No, this is my own declaration. I just chose to use 303 as that particular request.
Gotcha.
The third parameter is grant results, which is an array. So this array maps to this permission, all of those permissions. I suppose I really should be checking whether it was granted or denied. Which probably has to do with accessing the array, based on what I have been asking. Okay, but assuming it is granted, you go to camera permission granted, which then performs some additional operations. So control click. All right, so this is there's a lot of stuff going on here, but there's also a lot of stuff that has to happen later. So camera permission granted basically says, okay, we have permission to use the camera. Now what do? The first thing we do is to get a list of all the cameras, the IDs of all the cameras on this particular system. And I'm going to make an assumption that I want to use the first one, which turns out to be usually the forward-facing camera and not the rear-facing camera. Excuse me, take it back. This is the one on the back of the device that is, that's not on the same side of the screen itself. And then what I do is I get the characteristics of that particular camera. I don't really need to know most of the characteristics. There's only one thing that I really need to know. I need to know the stream configuration. So we are getting the stream configuration map out of the characteristics object. And then out of the map, there's only one thing that I really need to know. I need to know what kind of sizes is supported. So this part here is really hard-coded. I did not really specify any logic to do it. Now, I just picked 10 because of my Nexus 5 device. 10 corresponds to 800 by 600, which is which is a reasonable size for a preview. If you don't want this to be hard-coded for a particular device, then you have to specify the logic to say, okay, let's go through all the sizes and then use your own logic to figure out which one is the appropriate size that you want. Yep.
So each of the values in the array sizes is going to have an object that has characteristics that you can look at?
Correct. Yep. The best part about doing this in, you can do it in a debugger. So let me hook up to my phone so we can actually do it using a debugger. Then you can actually see what kind of sizes is being returned, so you know how you can choose it. Okay, so let me put a breakpoint here and run the program in debug mode. Okay, press OK. Use it. Okay, so we just stopped here. Installation failed with message. Install failed. Update incompatible. Signature do not match the previously installed version. Okay. You uninstall the existing app. Okay.
Run it again.
Well, because I did it at home, but I had a different ID. So it wants to do it again. I don't think using the virtual machine is going to give me the same kind of list, so I want to run this on this computer. So right now it shows me a dialog box because this is the first time I ran this particular application, and it asks, allow camera 1 to take pictures and record video ? So that's coming from the request permission code because none is permitted right now. Okay, and I'm going to say allow. And now we get to this code. So you can see over here that sizes is an array. In fact, it's an array of 17 elements. And then out of the 17 elements, we can see that it supports resolution, everything from the native resolution all the way down to 176 × 144. and 10 is the one that I thought, hey, this is just about right, to display on as a preview.
So it's just a list. It's just a string.
It's a list of supported resolutions. This is reported by the camera itself.
Okay.
So when you look at the output stream of a camera, these are the supported ones.
Okay.
Because the camera itself, can stream, in multiple resolutions. So if you specify this, when you specify the sync device, when you make this capture request, then it will basically inform the camera to use the most optimal way to do the streaming. So if I'm only capturing at 800 by 600, it's not going to stream, in the resolution of 3000 something by 2000 something, which is a waste of, bandwidth of memory transfer. It will just choose whatever, output of the camera is the most optimal to support what I need for this capture. Okay. So are there any questions right now about, how this code works? No questions? Okay. I'm going to just keep running the program, which at this point should give me a preview. Nope. Guess do the same code again. Yep. So now I have a preview of the camera. You cannot really see it, but it's just a tiny little window showing what the rear-facing camera is seeing. Okay. So it's nothing fancy, but it does make the connection. Okay. So we'll go ahead and continue with this stuff here. So the next thing I do is to remember what is my surface view. The surface view is whatever is in the layout. So I just use a good old find view by ID call to get that surface view. I can always, from the surface view, I can always get a holder. Okay, so that's always there. But when you have a holder, even though the holder has a get surface call, the surface may not always be there. So what you want to do is to add the holder. You want to add the activity itself as a callback to the holder. Okay. Now this is the tricky part. This is referring to the activity class itself, but when you look at the declaration of the activity class, it is also implementing a surface holder dot callback. Now, as a surface holder dot callback as an interface, it has to implement. Okay, let me scroll down to the ones that you have to implement. Those are some of the public methods down here. Okay, so one of them is surface created, and this is where we intercept the code, where we intercept the event of, okay, here is a surface created for this particular surface view. Is that part okay? Because this is one of the tricky parts. Okay, so let me go back to the code one more time. So we go back to this part here. We have a surface view, okay? So from a surface view object, you can always get its surface holder object, okay? But a surface holder object may or may not have a surface associated with it. So instead of saying, okay, get surface, okay, because I want to have access to the surface, instead of doing that, we basically add the activity class itself or the activity object itself to the callback and say, okay, add this activity object as a callback to the surface holder. It's okay because I implemented that particular interface with this class. So what that would do is to basically say, okay, if we have anything to do with if any surface is now available or changed or it's removed, let this object know about it. And that's what those methods are for at the bottom of this particular class definition. So if you scroll all the way to close to the bottom here, we have surface created, surface changed, and surface destroyed. These three methods are coming from the surface holder dot callback interface. Is that okay? So whenever the surface changes, we will get a callback here. So we can specify what to do if there's something specific to do. Now, right now, I don't have anything specific to do. Yep,
What
go ahead.
language you use? They're coming from the surface. What? These three are coming from where?
These three are coming from the surface being changed in some way in the surface holder. Well, the surface holder is basically your manager for managing the surface. So by adding an object of the main activity class, which is implementing the callback interface as a callback, then when anything happens to the surface, I will get notified, so I can decide what to do about
You
it.
being the main activity.
Yes, me being the main activity object. Yep. So let's go ahead and check out what we do when the surface is created. When the surface is created, it will come back, we'll get this callback with a holder being non-null. So what we do is we say, okay, let's go ahead and change the size of this particular surface based on M size. M size is remembered from one of the sizes that we got from the stream configuration map. Is that okay? All right. So there are many, many pieces, that need to be connected, and they rely on a lot of callbacks. Once we have the screen or the surface configured, then we can go ahead and actually open the camera device. So up to this point, we have not even opened a camera device. We inquired, okay, but we have not opened. We inquired the camera manager. Tell me all about, tell me what cameras are available. Give me all the IDs. Okay, here's a list of IDs. Tell me more about this particular one. Give me all the configuration detail of this particular one. Okay. Tell me about the stream configuration map of this particular camera. What kind of stream can I get out of this camera? Get the sizes, right? I just hard coded to pick the 11th one, using 10 as the index item. So now I remember the size or one of the supported sizes of that particular stream. Is that okay? But I haven't really requested the operating system and say, I need to use that camera. I'm just asking about, okay, what is supported, what are the characteristics of this camera. But I have not asked the operating system to use it yet. Is that okay? Yep, go ahead.
Are you going to tell it to use the camera or the screen? Do you tell it to use the camera or do you tell it to use the screen?
You tell it to use the camera,
Okay.
and then the surface is associated with the camera. And then the system will automatically decide, okay, if you need to capture, with a size like this, and the camera supports that particular size, it would just tell the camera and say, okay, let's go ahead and stream in low resolution because that's all the sync is requiring.
Okay.
Okay, so that's one chain. Okay, the other chain starts with a surface view. Okay, which is just an element in the activity itself, and then we get to the surface holder, which is always associated with a surface view. Okay, but we are not getting the surface directly from the surface holder. Instead, we're just saying, okay, this main activity object can handle changes to the surface when it's created, when it's destroyed, or when it's changed. So let me know when something happens to the surface included in this surface folder. And then right away you will get a callback with surface created because one is already created. Is that okay?
When did the surface get created?
It's up to the system to decide.
So how do you know that you got your call registered before? Or is it?
Even if it is existing before and you hang on to it, it will still make sure that you know about the surface that is already created. Which is great because because now it doesn't really matter when it is created because it can be created before you hook up yourself to be a callback. It will still give you a call back and say that, oh, since you want to know when the surface is created, let me know. It is already created. Which is what it's meant to do. The reason why it needs that callback instead of immediately coming back and say, or instead of having a call to request the creation of a surface, is creating a surface is time consuming and resource hungry. So it can potentially take a bit of time to get it done. And anything that can potentially take a bit of time to get done, it doesn't want to do it in the UI or main thread. It wants to kind of defer that to the operating system, because it is the operating system that is preparing these resources for you. So none of this, okay, is the request is done by the app itself, but surfacing the request is done by Android. And that's why we have all of these callbacks, because each one can potentially depends on how busy is Android, how much resources is available, how many other apps does it have to close to get this done. So it may come back in 5 milliseconds, it may come back in 50 milliseconds. So we don't want to hang up the UI thread just because we are waiting on something. Okay. All right. So now that we have the surface created and the size is configured, and if you don't do this part, it's not going to work. Tried it already, didn't work. Okay, so you have to set the size of the surface to one of the supported resolutions in order for this to work. Okay. Okay, so once you have done that, then we call open camera device, and that is over here. And you can see that there are many try-catch blocks, because every single time we do something about the camera or the camera manager, you may get a camera access exception or camera access exception, or security exception in this case. So you have to use all the try-catch blocks to do this. All right, so this is the call to open the camera. This is officially you or the app telling the operating system and say, I want to use this particular camera, identified by the ID, which is a string. Okay? So you can see the first parameter is pretty easy. Camera ID is nothing more than a string. In this case, just a string with 0 in it. Okay? But then the second argument is the callback. So once again, we are looking at a callback, which is basically saying the open camera call returns almost right away. Okay? Because all it does is to place a request to the Android operating system and say, oh, this app wants to use that camera. And it returns right away. And then the Android operating system will take its sweet time to process the request. Okay? So when it processes the request, then it will come back with one of these 3 potential callbacks. It can come back and say, yep, you got it. It can come back and say, nope, it got disconnected even when it was connected to begin with. Or it can come back and say, okay, there's something wrong with it, okay, with this request to open. Question?
So this object survives, so we could still get the on disconnected well
Yes.
after we get our on open. Right?
Yes. Okay. Yes, because this object is being passed to open camera, and depending on how the system is tracking this object, it can still be around when the camera device is for some reason not usable anymore. Okay. So assuming that we did open the camera device and the operating system says, okay, here is the object representing the camera, which is the parameter of this particular callback camera. So what we do, the first thing is we just remember the reference, because I need to access this from the rest of this class. And then the second thing we do is to call another private method called connect camera to surface. Because at this point I got both components. Okay, at this point I have the camera device object, which is representing the camera device, the hardware device that I need to access. And also at this point I have the surface in order to act as a sink. But these two things are disconnected at this point. I got the surface already done, pre-configured to a certain size. I got the camera device ready for my use, but these two things are not connected yet. Okay? So the next thing I need to do is to make a connection between the sink and the source, because I got both at this point. They're just not connected yet. So this call here, or this method, is in charge of making that connection. So the first thing we need to do in order to create capture session is to have a list of surfaces. And I just decided to use a linked list here. Any list will do, okay, but the linked list is one of those. So I just create a linked list and add the surface of the surface holder to this list. I know at this point that we have a service, because this code would not get triggered unless we got through the surface created handler of the main activity. Okay, so you can see there's a long chain of things that has to happen in order to get to this point. But this code is difficult to read because it's not in one single sequence, because it is interrupted by all of these things that are known as callbacks. You make the request comes back right away, but then the result of the request comes back later on in the form of calling one of the methods of the callback object. That triggers some additional logic to happen, which usually ends with another request of some kind, which has its own callback. And then you wait a little bit longer, and then one of the methods of that callback gets triggered, and then you say, oh, now we got this one, and then you run some of your own code, which is, again, doing the same thing. So you can see this long sequence of operations is separated or chopped up because of this kind of mechanism, which makes the code a little bit harder to follow. But that control click helps a lot. It doesn't help when you're writing the code. It helps when you're reading the code.
Absolutely.
Maybe alt click will help you write the code.
Well, sometimes it takes you to the API, so that becomes helpful too.
Yeah. Well, if you want to dig deeper into, okay, what does it actually do, right?
Yeah, when you look at the camera manager, you can jump right back to the class.
Yep. All right, so then we add the surface to the list, and then when we call create capture session, because we need to get a session in order to make the connection. So a session is basically an actual connection. So a session is just connecting these two things, making an association. But is it doing anything? Nope. Okay? So it's just a connection to say that, okay, this source is hooked up to these sinks, potentially. Because otherwise, it would not be a list. If it cannot be plural, then it will only be a single service. So the fact that it is a list of services, potentially, means that the same app can specify multiple sinks, each one being a service. You can have one for preview, and then you can have one that is actually for capturing and then do some image processing. Okay? So that's where your program is going to be different, because you need a preview, but you also need to hook up another service to actually capture it. But there's no capturing done at this point. I'm just making the connections. So a session is nothing more than, I would say, a logical connection between a source and multiple sinks in this case. But there's
Your
nothing
capture
really.
request really is a stream connection request.
Correct.
Okay.
Yeah, so this is actually happening after the capture request is happening when you actually want to do a capture. But you need to have a session opened first. Okay. All right. In other words, this is having a capture session opened is kind of like turning on the camera, like a good old camera. It's just turning it on, or uncapping the lens cap, but you're not taking a picture yet. When you click the shutter release, that's a capture request, and go like, okay, can I capture this, whatever the camera is seeing at this point? So once again, create capture session returns right away. Okay, it returns right away. It is up to the state callback object in order to say, oh, when it's configured, what do you want to do? Okay. So in this case, when it is configured, the first thing I do is to remember what is the capture session itself, because until this callback, I won't even have the session object itself. So this is the first time I get a hold of the session object itself. And then the second thing I do is to continue my own logic of setting up a preview session, because this is just a session. It's just a connection between the camera and the surface. But what do I want to do with that surface? Is it a one-shot thing, a snapshot, or is it a preview? Do I want to continuously update the surface? We haven't specified anything yet. Okay, this is really just saying that, okay, we have a connection between the camera device, and that particular surface, but we haven't specified when to do the capture or what we want to do with it.
Is it a connection between all surfaces?
It is a connection between all surfaces. Yep. Yep.
So what's the non-null, at non-null?
That is, it's basically saying that this parameter cannot be a null object. So when we get the callback, you don't have to check. It cannot be a null. Or when you call it, it will also check to make sure that it is not a null object.
If it is null, it just passes nothing to it?
If it is null when you, well, since I'm not calling it, this is a callback. If it is null, I'm suspecting Java puts in the code to give you an exception. Or
it says it can't be null. It says it can't be null, so.
Cannot be null.
Yeah, it cannot
Right.
be null.
Right. But if you are the one calling a subroutine that is marked as non-null with one of the parameters, that means for sure if you pass null NULL to it, it will complain about it.
It's an exception.
You get, well, no, when you pass any NULL to it, the compiler would catch it and say that, well, this is specifically non-null. But at runtime, if you pass something that is turned out to be null, does it give you an exception? I'm going to guess that would be the case. Okay, so now we are up to setup preview session. Okay, one more quick. Okay, so once again, we are trying something. So the way we do this is we set up a builder first. So the builder is of the class capture request.builder, which is a nested class within a capture request. And the builder is built with a particular template. So the template is preview, which means it automatically set up most of the things that we need for previewing. Okay, which basically means, okay, we need a higher speed type of setup. It doesn't have to be high resolution, and it specifies everything that goes along with a preview. And then the second thing we do with the builder is we add a target, and the target in this case is the actual surface. So if you are dealing with multiple surfaces, then you have to set up multiple requests at the right time. Is that okay? So if you want a preview so that it shows on the screen and then you have a shutter release button, that means the other request does not happen until you click on the button. But then it will be a different surface. It won't be the surface of the previewer. It will be a surface created by an image reader so that you can actually capture the image and then potentially save it to a file. Is that okay? So you have, you have to choose when to set up your request. In this case, because it's a previewer, I just set it up right away. As soon as I have the session open, I set up the request and say, okay, let's start capturing right now. But if you have a shutter release button, then you won't set up the request until somebody clicks the button.
And we basically do the same stuff.
And then you do basically the same thing, except your surface is not going to be coming from the surface holder of this particular object, because that one only corresponds to the surface view that is on the activity, right? So in that case, if you're capturing the image itself, then you have to use an image reader object, which has its own surface. Then you have to use that surface to specify the target for this builder. Okay? But otherwise, the logic is pretty much the same. And then the last thing we do is to have the builder to actually build the request itself. So the request is now done. And then the next thing we do is to send the request to this call. There are multiple set blah, blah, blah request calls from inside a session. This is only one of those, okay? The other ones are one shot. This is a repeating. There are also special calls to, I think, low latency type of requests. So they have specialized calls in this case, but they all require about the same kind of parameter. The parameter in this case includes the request itself, but it also has a potential callback. But this time it is optional. Yep.
I'm not sure, like, this you're streaming this one, so you called it right away and start streaming. But if
Right.
you're going to take a picture, you're
Right.
going to respond to an event of a click, right?
Right.
So how do you because this has been called because the session was ready, right?
Right, so you basically, if you're responding to a click, that means, this whole thing is going to be done inside a click handler. And on click would include
Okay.
this code.
Okay, so where you called this up above would not call it, you would wait for the click.
Exactly, so you won't be triggering the execution of this code to basically make a request and then send it to request the capture. So you won't be doing this until the click event.
Until the click event, okay.
Right.
Okay.
But since this one is only setting up a preview, so I can do it right away. It's like, okay, as soon as I got the connection, as soon as I got the session, I can start to capture.
So the part where it requests the session is what you're gonna put in the event of the click.
You still have to wait until the session is ready. So,
Do you do that after you click and then wait for the session to be ready and then?
No, you have to make sure that the session is ready before you even allow somebody to click it.
Okay.
So you might want to disable the button first until the session is ready.
And
Yep.
then enable the button, and then when it clicks, then you come in
Right.
and close like here.
Correct, yep. All right, so we are almost there. So this one, sets up a repeating request, which means, when one is done, it will automatically trigger the next one. And I did not specify any callback here. If I wanted to, I can specify a callback and say, when a request is done, let me know, and I can either keep track of a frame count on the screen or do something about it. But since I'm not planning to do anything about it, I just let it go. Is that okay? Okay. And that's it. That's the entire app. Because by this time, when this is all done, when this returns, then I actually will have the screen seeing whatever the camera is seeing, without any additional code on my part.
When you're back out of the activity, it releases the resource.
It should. I haven't specified that code yet. But getting to this part is the difficult part. Backing out is a little bit easier. But you can see how many times we have to set up a callback, by making a request, but then, but only when the callback is, only when the operating system is done, then it will call back.
Now, this is because we don't actually have access to the camera. We have access to an interface to the camera. The operating system's holding onto the camera. So we
Yep.
ask it to do something and it calls us back.
Yep, exactly. So the mechanism, if you look at the execution, the threading part of this is also the interest, because your own thread is not being blocked a whole lot. None of these calls are blocking calls. It's not like, in the socket call, in the socket, example, where we created a separate worker thread just to deal with the socket. Let's go ahead and read something, and the read operation is blocking. Okay, so in this case, we have one single thread. I did not create any additional threads. So what's going to happen is, this is your UI thread, and you only got one thread, so it has to be the UI/main thread. So the UI thread will come to a certain point, and it is going to call one of the methods of these objects that triggers an operating system concept, or trigger an operating system operation. So what happens is, it will go to the operating system. So let's say this portion is part of Android. So it will go into here or do whatever is necessary to send a request to the Android operating system, and it comes back right away. When it comes back, most of the time it goes back to the beginning of the main loop and see what else it has to do. It can be drawing something on the screen, can be answering something from a socket, whatever. Okay, it doesn't matter. And then at some point, it's going to block itself and say, okay, I got nothing to do now. The operating system has its own threads, multiple threads. So the operating system is working here, and they go like, oh, okay, I can pick up this particular request now. And then the operating system will go like, oh, okay, camera 1 wants to know what devices are available. Fine, we'll go ahead and do some processing. When the operating system is done with this particular request, what do you think it's going to do? It will do the callback. Now, but the callback mechanism, we only see one half of it, because we only get to specify what object we're passing to the operating system. When the operating system is done, it is not only just passing the object back to us, because it has to specify at least 2 additional things. Because within a callback object, there are multiple methods. So the operating system has to specify which method should be triggered. And if it has parameters, the operating system will also have to specify what parameters should be used in that particular callback method. Is that okay?
It really just sends a message to the Android message pump in a sense.
Yes.
And then that invokes the callback.
Right.
Okay.
So the operating system is going to put something back into the loop, back into the message queue. But the message, that particular message, includes the original callback object along with which method should be called and what parameters should be passed to that particular method. So when the loop pick up that particular message, then it knows what to do with it. It knows who to call and what to pass as parameters. Is that okay? What if do you think you can have multiple threads that can also handle this sort of thing? In other words, are we limited to only one thread being able to do the loop and the message queue, or can you create additional threads that also have their own loop and message queues? You can actually do it. You can do additional threads that can do this, okay? But the thing is, whatever thread is requesting is whatever thread is going to get the callback. So you have to be very careful, because if the callback involves you doing something on the screen, then you have to do the request from the main thread itself, because the callback is going to be calling back the same thread. Is that okay so far? Okay. So the notes does go a little bit further than this. Okay, first of all, it explains why we have all these callbacks, because there are many callbacks I didn't count, but you guys can help me count that. And then the last one is to talk about what if you want to take a picture. If you want to take a picture, you want to use Image Reader as a class. So if you look up Image Reader in Android developers, it is just a class that allows direct application access to image data rendered to a service, which basically allows you to process it. If you want to do any type of image processing, go ahead, knock yourself out. You can get the entire raw image to process. If you want to save it, you can save it too. It depends on what your intent is, which template you use when you specify the session. Because, yeah.
What part of the code was the session? Was it the end piece or right before that?
The part to open the session is right here. So create capture session. Nope, not this one. Request builder. Okay. So this is how you specify what you plan to do with it, and having a preview is one of the templates, but you also have other templates as well.
And this one says it's more based on frame rate, less on quality.
Mm-hmm.
But if you say that you were planning on taking a picture, it wants to be more on quality, less on frame
Correct.
rate. So if you've configured the camera here, is it configured differently for the surface for the image view?
Okay. So for that, it might be helpful to look at a capture request, because they give you a pretty good table actually. There's a really good table in capture request. You can see how long this document is, because they actually explain multiple ways to combine stuff. May not be this one, but there's one document that gives you a table. Of combining, if you have multiple surfaces, depending on how you combine those things, it will give you a different recommendation of how to set those things. Let me see if I can look that up.
Capture request builder.
Nope, not this one. The other one that I'm thinking about, has a picture. And we want to switch to images because I can recognize the table if I see it. Ah. I saw that earlier, not in the class, but when I looked up the documents, I was able to find that. But I cannot remember where it is located now. Capture a session, request creation, submission, source. Nope, that's not it. Okay. I'm just going to do a quick investigation here. Okay, so these are the actual definitions of the templates. So when you look at these templates, let's see if it might have some clue here. So with manual, it automatically disables all the automatic control. Post-processing parameters are set to preview quality. With template, with preview, a high frame rate is given priority, so it can choose different things. And the record is for video recording. We will need a stable frame rate, and post-processing is set for recording quality. Still capture, high quality, low frame rate. And there's a picture, I remember there is a picture that shows a table of what happens when you have multiple services and you have multiple things that you need to take care of. What do you need to specify in those cases? There we go. Just have to go further now. Further down. Okay. So legacy level guarantee. So if you have multiple targets, each target is a service. So if you have multiple ones, depending on what you need to do, if one is preview, one is maximum, and then one needs a JPEG, and one is private, then the standard still imaging. Oh, okay. So these are the use cases. Then you look up, how to set up the multiple targets. Okay. So this is how you read this table. You read this column first, pick out what you want to do, and then you have to set up the target like this accordingly.
What is YUV, do you think?
Sorry?
What is YUV?
That's a video encoding scheme.
Oh, okay.
Supposedly more efficient than a raw type of encoder scheme. YUV encoding. It's a color space typically used a part of the color image pipeline. YUV is commonly used in computer industry to describe file formats that are encoded using YCBCR. Okay, let's take a look at this. So U is along this axis and V is along this axis. And then the Y is probably be luminance. Yep, Y is luma, and then the UV go in these two different axes. Why is it called UV? Chrominance. Chrominance are the UV components. So there we go. For whatever reason, this is a common standard for video transmission. Instead of using RGB, for whatever reason, it probably has to do with properties of sensors, at least in the past. I know, the chroma information needs to be separated on its own channel for black and white or monochrome, systems.
I think they're separated on the right in that column there with the picture.
Mm.
You say that's YUV right there. There's the picture.
You mean here?
Yeah.
Yep, that's the RGB. This is just Y, and these two are probably U and V. But I don't understand why they use U and V instead of some other ways of encoding it. The YUV model defines a color space in terms of luma and two chrominance components. The YUV color scheme is used in PAL and CCAM composite color video standard, but not in NTSC. So NTSC uses a different standard. Color information was added separately via a subcarrier, so that the black and white receiver still be able to receive and display color picture transmission. Y stands for the luma component, UV are the chrominance color component. But I'm not sure why they chose to use those two UVs to span the space of color space.
U and V just because they didn't want to have X and Y. They're already using Y.
Okay. And then NTSC uses the YIQ color space. Is related, although more complex. So YUV is still used a lot, as a transmission standard because of the historical reasons. Most sensors today are RGB based. If you look at the Canon cameras, they're actually RGB based. So to convert it back into this format, there's actually you need to do a lot of computation to convert it back to the YUV standard. But if you have any type of analog camera and you want to convert the analog camera into a digital version, then this comes in handy, because some of the analog closed circuit cameras, especially in Europe, using the CCAM standard, actually has 3 channels, because it corresponds to the 3 analog channels coming out of those cameras. So your digitizer to convert the analog signal into a form that your computer can read would just say, oh, okay, there's 1 channel for each thing. So your conversion circuit becomes really easy to implement. But then your software now has to combine YUV back into RGB image. So that's just basically math. How many people know what a color space is? Because that's just a terminology that we just threw out here. No. Okay. So the color space refers to what colors can actually be rendered, and how do we specify a particular color in the color space. Okay, and there are several really common color spaces for those of you who want to kind of know a little bit more about this. One is called sRGB, which is a standard, and this picture, if you're really into photography, you probably have seen this picture, several times. So this picture shows, the color space. Let me see if I can get a. Nope, this is not a bigger version. Okay. Try to get a higher resolution version. I can specify resolution in settings. And specify,
Goes under more or tools. They moved it.
yeah, I think they moved it a little bit. Tools. Yep, there we go. Size, large. Yeah, this one's a little bit larger. So this is a color space. And then the interesting part is this inner triangle here is what a computer can actually render on an RGB monitor. Okay, and then the entire color space is what your eyes can actually perceive. So what do you notice about that triangle? It's a lot smaller than the entire color space. So what that means is, when you go outside, you look at the blue sky, you look at the green leaves and stuff like that, you take a picture of that, okay, using the most expensive camera that you possibly can buy, and then you display that image using the most expensive monitor you can buy. There's still colors that cannot be rendered by the digital mechanisms that your eyes can actually see. Okay, yep?
Is that the case with analog and film too, or?
That's not true with the films, because the films do not use the RGB color space. In other words, a color is not represented by how much red, how much green, and how much blue with traditional film. Traditional film, use different mechanisms to encode colors. So it might have its own restrictions, okay? So that there might be some other colors that may not be rendered using traditional film, but it's not going to be the same as the RGB space. Okay? Now the RGB space is only used for monitors because we got RGB pixels. What about print? Has anyone tried to use a magnifying glass or a loupe to look at like a magazine? What do you see?
Dots.
You see dots, but what colors are those dots? Are they RGB?
CMYK.
It's CYMK, okay? Because RGB is an additive process. When you mix RGB to all the different colors, it's called an additive process. So when you combine, okay, as an example, red and green, what do you see? If I have one really bright red LED and right next to it is another bright green LED, and you're standing really far away, so you cannot really see these two individual LEDs, but your eyes just kind of blend them together. What color do you think you will see?
Yellow.
Yellow, exactly. So red and green together is yellow, okay? So this is how your eye can kind of blend RGB into different colors they can perceive. But remember, with only red, green, and blue, there are some colors that your eyes can see but cannot be rendered by RGB. But when you read a magazine, it's a deletive process, which means we are filtering out what we do not want the paper to reflect. Okay, so that is a different space because it's no longer additive. You're not saying, oh, here's red, here's green, let's add them together, it becomes yellow. It is now a deletive process. So it uses what we call CYMK, cyan, yellow, magenta, and black. The K stands for black. So that's the color space for prints.
And
Yep.
it has to do with reflective light?
It has to do with when you're reading from a piece of paper, it is reflective.
Okay.
So when
Versus
it's-
a monitor, which is projective?
Which is, which is projective, or it is an additive process. Yep. And then when you look at wide UV, that's a whole different color space too, because it's separating into luminance, and then plus the two color spaces. But it has a weird way of separating the colors, which most likely has to do with the sensors of traditional color cameras, analog color cameras. Because back in those days, they might have a different type of sensor technology, so that the color space is just, electronically speaking, it's easier to make it that way than having RGB space. But since we are now in a digital age, all of the cameras that we have now are RGB based. So color space is an interesting thing. If you're really into photography, you can spend easily hours and days and weeks, to tweak the color space of your pictures. Obviously, nobody here seems to have experiences doing that. Okay. Yep. Oh, you do. Because depending on the lighting of when you take the picture, it can influence what you actually see in the picture, because the color temperature changes depending on the background light. When you go outside right now, full sun, what is the color temperature of a full sun? It's about 4,000 to 5,000 kelvins. And with color temperature, okay, I know we are kind of a little bit getting out of the Android programming realm. When the color temperature goes up, it looks bluer. When the color temperature goes down, it looks kind of yellowish, orange even, okay? But depending on the background light or whatever light is shining on the object, what your eyes perceive as a color will change as well. But we have a very good automatic white balancing algorithm. So to us, whatever is gray remains to be gray, because we have that automatic white balance feature, so it doesn't bother us nearly as much. But when you take a picture using a camera by itself has no automatic white balancing mechanism. So when you're taking a picture under full sun, as opposed to evening, when the sun has set and the color temperature has lowered, then one will look kind of yellowish, the other one will look kind of bluish. So when you compare those two pictures side by side, the same thing that you're taking will have a different color. So the question now is, how do you adjust for that? Now, with most cameras, it has an automatic white balance algorithm already built in, which works most of the time. How do you think that mechanism works? How does automatic white balance works? So let's put yourself into the shoes of your sensor, okay, which is now related to Android programming, and you say, okay, turn off automatic white balancing. I'm just getting whatever the raw sensor is reading. Okay, so there's no automatic white balancing. So what do you do in order to establish, oh, okay, I think this is white? You pick out the pixels that you think are the closest to pure white, with a high value of R, G, and B. Now, they won't be exactly the same depending on what time of the day. Is it under fluorescent light? Is it under tungsten light? Is it under LED lighting? Okay, they won't be exactly the same. So the RGB will be in a particular ratio, but it's close to white. So an automatic white balancing algorithm will just pick that and go like, I'll consider that to be white. So this is the ratio. So in order to white balance the rest of the picture, it will just say, okay, I need to bring this red all the way to the same level as green, and I need to bring the blue all the way down to the green. So it has a multiplier to each of the color channels, and it will just apply that multiplier or that coefficient to all of the other pixels.
So if it's 5% to white and 5% everything else.
Right. I think it's completely just ratiometric. Is that right, or is it not entirely ratiometric? I think it's just completely ratiometric, but it can be tricked. Okay, so the way it can be tricked is you look at the picture, and out of the entire picture is completely yellow. Okay, or it has no white pixels whatsoever in the entire picture. Your algorithm will still try to pick out the one that is closest to a white pixel and say, I'm going to call that white, and then I'll adjust the rest of the picture, making that assumption. So if you're looking at a picture where it only has different shades of yellow, orange, and red and stuff like that, and then the automatic white balance thing will just try to white balance it, so your actual image will no longer be representing the actual image. It will be representing an altered image based on that automatic mechanism. Yep.
Can you put something in the picture that's really white? Can you help it?
Yes. So in photography, they call these things white gray cards. 18%, if I remember correctly. Yeah, 18% gray is It's weird because they use a logarithmic scale, so 18% gray is actually quote unquote in the middle. So what you do is before you take the actual image, you put a gray card into the same scene, so it's under the same lighting condition. So you take that reference picture, it's not a part of what you will actually publish. And then you take all the other images, but you only record the raw sensor readings. So you don't ask your camera to do any type of white balancing or any correction. When you do the post processing, then you take a look at the first reference picture, because the gray card is always neutral gray. So you use that to help you establish the ratio, and then you can correct the rest of the pictures under the same lighting condition. And also the 18% gray can also help you with adjusting the luminance too. Because the other thing that's automatic that we don't even think about these days is automatic exposure. How does the camera do automatic exposure? When you go outside, it automatically will expose correctly so that things do not look too bright. When you go inside, things would also look just right without looking too dim.
That means shortening the amount of time you allow the
Right.
right?
But how does it know how much to adjust, right?
It like shoots a green light out or something, doesn't it? Like shoots some sort of laser or something.
Oh, that's a focal laser.
That's for
That's what that is?
focusing.
Yeah, like right before you can see it like.
It's just gonna be about the amount of light that it lets in.
Right, but it has a standard. It wants 18% gray.
18%.
Huh? Is it 18 or 30%?
You're right, it's 18.
18% gray. So it wants to average all the pixels of the entire image or a part of the image, depending on how you want to set it up. Okay, but the quote-unquote correct exposure is 18% gray. Okay.
So does it look for it in the picture?
It would adjust the shutter speed so that 18% luminance is achieved.
Okay.
Now, if you're in a concert, okay, where the background is completely dark, and then whatever the singer, the performer is under the spotlight, your algorithm will still work the same way. But now you have a whole lot of dark pixels in the background, so it will try to increase the exposure so that the few non-black pixels will offset the rest of the black pixels, so that the average will be 18%. And that's why you have overexposure of the performer when you have a really dark background. And the opposite is right too. When you try to take a picture of somebody who's standing against a bright background, backlit, it will do the same thing. It wants the entire thing to be 18% gray. So all the bright stuff from the background will offset it. So now the actual thing that you want to record correctly is all underexposed because it is backlit.
So it's trying to average the entire thing to 18%, right?
Or depending on the algorithm. So if you do this processing yourself using the mechanism that we just talked about,
Right.
you can have your own mechanism to decide what is going to be my shutter speed, what is white, and so on. So you can now say, okay, do I want to just use the entire picture, which is just averaging, or you can weigh it too. You can say, okay, I'm going to put more focus on the center, less weight to the sides and whatnot. Conventionally, if you go back to the old SLRs, this is called matrix metering, which is basically dividing the entire frame to multiple sections, and then using a quote-unquote AI algorithm, you try to determine which section has the main thing that you want to take a picture of and needs to have the right exposure. So, back in the good old days, between, Minolta, Nikon, and Canon, they came up with all kinds of different AI algorithms and all kinds of mechanisms to quote-unquote get it right. But the problem is not solved. The problem has never been solved because even the computer looking at a picture can never really quite figure out what is of interest until face recognition comes along. Okay? Now, but with facial recognition, it still doesn't know the right exposure because different people have different complexion, and it wants to make everybody gray, 18% to be precise. Okay, so if you're shooting somebody with a darker complexion, the actual record complexion will be lighter than the actual complexion because it wants it to be average. When you take a picture of somebody with a lighter complexion, it will look darker because it wants that average. So the only way you can do it correctly is to hold out a gray card with a known reflectance, 18% to be precise, and then the camera needs to know, okay, that's a gray card, and then use that as a reference point. And then once you have a reference point, unless the lighting is changing, then you can keep the same setting for the entire session, under that kind of lighting condition. Fun stuff, photography, yes. But now all of you guys who are basically photography buffs, okay, I can see one, and myself mix the second one. Now we can capture all of these images using Android, and then we can do our own analysis of whatever the image has in order to determine how to fix it. Yeah, it really is fascinating. I actually spent an entire summer, to figure out, how to do color space conversion, how to, make things look right, in the wrong lighting condition, it will still look right.
And that
Yep.
triangle, the things outside the triangle, you can't display. There's no way to make the pixels.
That is correct. It basically means, your eyes can perceive, but your monitor cannot produce.
So you really can't see that outside the triangle. It's just an imagination.
That's correct. Not from a projector. No, you cannot see it from a projector.
That's just your imagination.
Yep, but it's interesting. So what that means is, if you take a picture of some plants, because most of the stuff that you can perceive but you cannot project using a computer display are greens. Okay, all different shades of green. So that means that if you take a picture of a plant that is outside of the gamut, okay, so if you take a picture of a plant with kind of green like this, okay, and then you make a print out of the image, okay, use the best print shop you have, then you go out to the actual plant and then you compare the two, then you start to see the difference. They're not exactly the same. Which is fascinating, because our eyes actually have a wider gamut compared to our technology.
But similar to audio when it's just we can't go with the same frequency, or we don't have as many bits in the depth of the tone.
With audio, digital technology is actually can complete the resolution of your headphones combined with the DAC or the digital to analog converter of your phone can produce sounds that are original, that you cannot tell the difference from the original. That has to do with, because it has no space to speak of. The space thing has to do with how we perceive colors, because we got two types of cells to perceive lights, right? We got the cones and then we got the rods. The cones are the ones that can see colors, and then the rods are the ones that are black and white, but they're really sensitive. So at night, we cannot really see colors nearly as good, because only the rods are responding to the low lights at night, so we cannot see colors. But we can still see images because the rods are working. But it has to do with the cones, and how the cones encode color. And there are different cones to encode different colors. And it's just a matter of how much of each one, how much of each wavelength that we are encoding, and that forms our own space of what we can perceive. And then the RGB is another 3 colors to try to span the entire space, and it just turns out that it cannot span the entire space that we can perceive. But sounds are different, because sounds are linear, so there's no quote-unquote space to speak of.
So they're close enough together that we can't perceive the difference, basically. When you're
You
going
mean for sounds or for?
a digital note, going from this to the note to that note, in an analog, but it's only playing an instrument.
So
It gradually goes, right?
I mean, if you took a signal analyzer and you looked at, I don't know, a regular instrument, it would be a sine wave. But as soon as we start sampling it and reproducing it,
Yes.
you know, we're gonna try to do a sine wave, but.
Okay, so to make it extreme, let's say this is the actual sound wave. Okay, it's continuous, you know, it is not digitized. Your most digital technology today would digitize it, so that means, you know, we have these individual samples to record at what time, you know, what kind of air pressure is presented to the recorder or to the microphone, right? So you can see it's kind of jagged. But when technology improves, we can sample with a higher and higher frequency. And then another problem has to do with what is the steps, what are the steps here? With a low resolution encoder, that means we are making fewer but wider steps between the samples. But with
8-bit versus 16-bit.
yeah, but even with 16-bit, some people can tell the difference.
Yeah, there's still spaces, there's still squares in there.
Yeah, but technology is getting to the point where, you know, we can easily have 22-bit, you know, sampling. Now, when you go from 16 to 22
If you have a 60
bit,
kilohertz signal in there, you're going to catch it maybe. I mean, if you have a higher frequency signal that you're trying to.
But we can
capture.
only hear up to 20 kilohertz, even with, you know, people with super good hearing. You know, the envelope of human hearing is only about 16 kilohertz, not even 20. And so in engineering, they say that if you want to record, you know, 16 kilohertz, your sampling has to be at least twice of that, so 32 kilohertz. Now, technology is easily to the point where we can record at, you know, 100 kilohertz if we want to. So at which point, you know, your sampling is, you're so much oversampling what you can actually perceive, it won't make any difference.
So that's why the CDs run at 44.
CDs only run at 44, and then some people still claim that it's not, doesn't sound like the original, because the number of bits with the CD, I think, is only 16 bits, and that's why, you know, some people can still tell a difference because it's not having enough fineness in terms of the steps. But the encoder technology can easily go to 22 bits, you know, these days.
And the speakers can play the entire range of.
That's
Speakers
up
are
to,
analog.
yeah, speakers are mostly analog.
Well, when they push the sound out, yeah. Well, I guess
Yeah, by the
most
time they get to
analog.
the driver, it is entirely analog. So now it depends on your driver technology, and that's why some people pay like $500-600 easily to get a good pair of cans, you know, because they want the most natural reproduction of the actual sounds. And that's an analog thing, and it's definitely a craft to figure out, you know, how to get it done. Until we figure out how to excite the nerve endings directly.
Same with the eyes, right? We can excite the nerve.
Correct. If you can excite the nerve endings directly, then there's no issue with color. Well, there will still be color space issue because it has to do with the camera itself, you know, sampling the outside world. So if the camera itself is still RGB based, then it cannot perceive, the camera itself cannot perceive anything outside of the gamut of RGB.
That's bits, different bits.
It's not the bits, it has to do with the frequencies that we can perceive. Our cone cells,
Frequencies of visible light. But in a sense, that's the same with audio too. Right?
but audio is different.
Much lower frequency.
The way we perceive audio, does anyone know how your
Little
ears?
tiny hairs might be
Yeah,
on
but
the
it's
bones.
inside the snail shell. You're inside your inner ear. So your inner ear is a snail shell like that, right? And then you have your nerve endings, you know, all the way around into the center. So depending on, you know, so each one is corresponding to the sampling of one particular frequency. So your ear is actually not hearing the actual air pressure itself. It is already separating the sound into multiple frequencies, and it has, you know, a quantity for each frequency that you can sample. Because the more you go inside, I think the higher the frequency. It has to do with the shape of the snail shell, you know, because in the inside it is the smallest, so only the high frequency sound can go into the innermost part of it, and that's also where we lose first, is the high frequencies.
So does deafness cause baldness?
Sorry?
Does baldness cause deafness?
Yes, the
All
baldness,
ears.
the baldness inside your inner
Ears.
ear causes, you know, loss of hearing. That is correct.
So what are the hearing aids doing? Are they just magnifying the sound?
Yeah, they're just amplifiers.
Amplifying.
but they can be customized to, depending on where your hearing losses are, they can amplify just that portion. So it's not like amplifying everything, because they do all of these hearing tests to figure out okay, most people can hear this, and then some people start to taper off when the frequencies go into like maybe 10 kilohertz or something like that. So they can customize the response of a hearing aid device just to amplify those particular frequencies, so that it doesn't over amplify the ones that you can still hear correctly. So a lot of this stuff is really interesting. And for those of you who are really interested in this type of thing, there's a shrimp called the Mantis Shrimp. And they're interesting in many, many ways. But they have an entirely different color space than we do, because they can see into ultraviolet as well as infrared. So what they perceive as quote-unquote color is entirely different from ours. I cannot even imagine what they would see or what they perceive by looking at things. So when they look at the monitor that we have,
It's black and white.
they just see like, that's boring. And same thing with Octopi too. Octopi, it turns out to have higher resolution, with their retina than us. So when we look at a 4K image, at Costco, right? We go like, wow, that's almost like the real thing. In Octopus, we look and go like, I see pixelation. Yep, fun stuff. So, with all of these tools, I want you guys to think about your apps, okay? Because now we have enabling to do all of these things. Sockets to network connections. We have, SQLite to store stuff, locally on the device. We have camera, access. We have sensor access. So
we have services in the background.
We have services in the background. You can do things in the background, that is not up in the front end. Yep. So we got a lot of mechanisms now. So if you guys can think of anything else that you want me to talk about, we can do that. But I want you guys to start to think about, okay, with all of these different mechanisms, what do I want to do as the project for this class? We got 8 weeks left, so it's not a whole lot of time.
Microphone next.
Microphone is next, but I would imagine microphone is similar to video capture, but easier.
So we were going to do image manipulation on
Right.
the canvas, or not the canvas, the surface. It would be the same as if we laid a picture in the surface,
Correct.
versus getting the camera to feed the
Right.
surface.
A surface is
So all
basically
that processing is the same regardless.
correct,
So
because a
once you-
surface is a frame buffer. It's basically a frame buffer, but
Would it be
using.
considered raw? It's not in JPEG. It's not in a compressed
It
form.
is raw. Yes, it is raw, which means not when you're in a preview. Okay, when you're in a preview, then it's no longer raw. It's actually the thing that you can see. But when you look at the actual, when you use image reader, the surface inside an image reader is just a representation of what the stream is feeding you. So it's not automatically converted into pixels in RGB. Can be in JPEG, for instance. So it depends on what you want to specify when you capture, you have to specify what you're capturing. Right? Yep.
I have two I would like to see covered. One is the Google platform, the Google identity platform. So we use to do logins and stuff.
Okay.
And the other is actually deploying to Google Play. How do you actually go through the steps of doing that?
Okay, so we want to go over Google Play. How do we publish apps in Google
Yeah.
Play? And also how to use Google Identity so that you can use one single sign-in, use your Google sign-in for any app.
Yeah.
Okay, we can look into that.
Yeah.
Yep.
I've also been looking at documentation on the Android Studio
Mhm.
page, and I found OpenGL
Mhm.
for the 2D animations.
Yep.
It said it could run it a lot faster than Canvas ever could.
Right, Canvas is an older idea, which is mostly 2D based, and OpenGL makes use of the graphical processor that is also, inside most of the cell phone these days.
Yeah.
Yep.
So you think that'd be a better way to develop like a game or something? Is it-
Oh yeah, I mean if you're developing a game like a 3D, first person type of game, you definitely want to use OpenGL for that purpose. But I have no experience with OpenGL on any platforms. I can learn about it. The person to ask is Dave Fox.
Hey, Bob?
Yeah, so Professor Fox, had some OpenGL experience when he was a graduate student. So he would know more about OpenGL than I do, but I can do some research and find out at least how do you hook up to the OpenGL library in Java. Okay. Yep.
Splash screen. How do you use the splash screens when your app is first starting, so that you can do loading settings and stuff in the background?
That is probably just an activity that is kind of special, that's full screen, and then when you do all the other stuff in the background, I don't think it has anything too special, but I'll add to the list. I'm just using Notepad here so that I don't have to listen to myself to remember what. I just need to scroll to the end and go like, okay, yep. So we want to deal with audio. Google sign in. What else?
Using Google Play.
Google Play.
And
How
their
to publish.
beta testing functions as well.
Sorry?
Also the OpenGL.
OpenGL. Yep.
We used to have it where we could, or in the last class where we could have a web page inside of or view a web page. Is there
Okay.
something in Android or
Yeah.
Java that
We'll
does that?
view. Okay. I think it's called a web viewer or web view.
That's what I think it is. Yeah.
Yeah. Okay. Anything else? I'm just collecting my. Yep. Go ahead.
Could you go over something when, when the phone talks to takes text and it reads it to you?
Assistive technology.
Yeah.
Oh, like text to voice.
Yeah, text to voice.
Text to voice. How to access that interface, because it's already built into Android. So the question is, how do you specify what text to send to that particular mechanism in Android? Yeah, so that could be interesting. All right, cool. And of course, once you have that, we also have that too. Okay, so I'm gonna keep track of all of these items. That's going to be my backlog.
There you go.
Yep. We have multiple suppliers of the backlog and one person to kind of empty out all the backlogs. Team of one, yes, go.
Go Scrum Master, go.
I'm the Scrum whatever, right? The Scrum whoever. I'm the Scrum Master. I'm also the
Project owner.
Yeah. That makes project management.
And he's the developer.
Yeah.
Cool. Okay, so we'll go ahead and work on these items one by one. So think about your project. I'm trying to enable all of you guys to do all of the things that you want to do.
8 weeks to do them.
Yep.